find the equation of a line. Let's look at a word problem having to do with lines. Okay, so let's say you have this problem. It says, imagine a tank full of water. You want to empty the tank, so you open the drain up, right? You also start a timer when you open the drain. The tank started with 200 gallons, and when the timer reached 2 hours, the tank still had 150 gallons left of water. What linear equation will predict how many gallons of water, G, are left after T hours? At what rate is the tank draining, and after how many hours will the tank be empty? So they've got 3 questions here. They want an equation that it tells us, how fast this tank is draining, a linear equation. They want to know the rate at which the tank is draining, and they want to know when would the tank be empty. Okay, so let's give this one a try. Okay, so notice right off the bat that they say that the gallons of water, they want that to be G, and that hours, they want that to be T. And so we're already looking at, our coordinate pairs, or like the way we look at this. We're going to be using coordinate pairs that are T comma G, in other words, hours comma gallons, right? Usually you always make the time your X value, or your first value in your coordinate pair. And also notice that they pretty much gave us 2 coordinate pairs. They said when the tanks, you want to go turn that on real quick? Sorry about that, hopefully you can see everything still. They say the tank started with 200 gallons, and that's when you started the timer. So right when you start the timer, that means you have time equals 0, right? So we already know that one point that we can use here is going to be 0, comma 200. Okay, and they also say after 2 hours, okay, so that was like started going with 200, right? They also say after 2 hours, the tank still has 150 gallons. So that's at T equals 2. At T equals 2, your G, gallons, is going to be 150. Okay, cool. So these are 2 points that we're going to work with. And so you might already be realizing, hey, we have 2 points. We could already get the equation of the line by getting the slope between those 2 points and then using point-slope formula, right? And so that's what we'll do. So first, let me go and move this over a little bit. Let's see if this will work. So I'm going to go put these points right here. And then, let's go ahead and continue. So we're going to use our slope formula first, right? So that's n equals y2 minus y1 over x2 minus x1. Except since we're dealing with t's and g's, why don't we just rewrite this as, forgot to click that, g2 minus g1 over t2 minus t1, right? Okay, and so what that's going to be is, see if I could squeeze it in right here, g2, right? If we consider this our second point, then this is going to be g2 right here. It's going to be 150 minus g1, which is going to be 200, over x2, or actually it's t2 in this case, right? t2 is 2, right? Because we're saying this is our point 2, and this is our point 1, right? Let's make that clear. So t2 is going to be 2, and t1 is going to be 0, right? Okay, so 150 minus 200 is negative 50. 2 minus 0 is 2. So we've got negative 50 over 2, which simplifies to negative 25. Alright, cool. So that means that we're going to have a slope of negative 25. Whoops. And remember, slope is a rate of change, right? And in our case, it was the change in G's, right? Change in gallons over change in T, which was time or hours, right? So this negative 25 is actually negative 25 gallons per hour. So this already actually answers our second question, right? It says, at what rate is the tank draining? We already figured out. it's draining at a rate of 25 gallons per hour, and since the value is negative, that's just telling us that the water is decreasing, right? The amount of water is decreasing by 25 gallons per hour, so you're losing 25 gallons per hour. Okay, cool. So now we have the slope. So let's move down here. And let's go ahead and get the equation of our line. So remember the point slope formula, right? It's going to be, it was y minus y1, all that, right? But instead of y's, we're going to use g's, and instead of x's, we're going to use t's. So let's do g, right? That was supposed to be a g. Okay, so g minus g1, which we'll just go ahead and use this point because it has a 0 in it. There'll be less calculations, so we'll use this point right here. So our g value for this point is 200. So g minus 200 equals m, right? Slope, which is negative 25, times t minus t1, right? That's what it would say next. So we're going to put t, and then our t value is just 0. Okay, so this is going to be g minus 200 equals negative 25t, right, if I multiply these two. And then negative 25 times 0 is just 0, so that's it, right? It's just going to be plus 0, basically. So, and then we'll just get our g by itself. So we'll add 200 to both sides. Let's go ahead and move this up a little bit, make that easier. So we'll add 200 over here, we'll add 200 over here, and we're going to get g equals negative 25t plus, let's make this more obvious, that's, whoops, negative 25t plus 200. And then this is a t, by the way, I know it looks like a plus. So that's the equation for our line that tells us how fast and which rate are we losing water from this tank, right? And so if we were to graph that really quick, like really rough estimate, our y-intercept is 200, right? That's our b value from, remember that from before? So we'll say that's 200. And then we have a negative slope, right? Negative 25. So our graph is going to look something like this, right? And then this would be our g-axis, this would be our t-axis. And so the following question, the last question, just says, how long until your tank is completely empty, right? No more water. And remember, g is how much water we have. So when the tank's empty, the amount of gallons we have left is 0, right? So really we're looking for when g is equal to 0, which would mean on this part of the graph, right? And so you could look at the graph and solve that, but another way to do it is just to plug in g equals 0 and solve for t. Okay, so if we say 0 equals negative 25t plus 200, what we can do is we can solve for t now, right? So subtract 200 from both sides. Oops. Since we subtract. Okay, so then we're going to have negative 200 equals negative 25t. And then now that we have the t over here, this is the only term over here, we want to divide by the coefficient of t, right? Or just get rid of that negative 25 by dividing. So divide by negative 25 on both sides, right? Okay, and oops. So now, negative 25 divided by negative 25 is 1, right? That's the whole point. And then over here, we're going to have negative 200 divided by negative 25, which is going to turn out to be 8. Right? Negative divided by negative. And so we have t equals 8. What does that mean? That means 8 hours. After 8 hours, your g value will be 0, meaning you'll have 0 gallons left. And so that's just telling you that right here, this t value right here would be 8 on our graph. Right? And then just to be clear, I only included the first quadrant. Forgot about that word for a second. That's why it looked like this, right, instead of like this. But same thing, right? So basically after 8 hours, you're not going to have any more gallons left, and so that answers the question. And so that was basically our t-intercept, right? Cool, so we just finished answering that word problem.